to idea. This is the process that actually runs the experiment to collect the results. Starts by preparing the files and folders to run the experiment and save the results, which includes copying the templates folder to a new results folder, so we can update the results in there, and also reads the baseline results for context, so the model can alter the vanilla code for its own experiments. Here we get the code, save the results, and save the log. Next, try making a coder chatbot with the model selected from the CLI call. That's the command line interface call from earlier. Try to run the experiments, handling errors as they come up. If the experiments failed for the current idea, then stop here and go to the next idea. In this section, we prompt the LLM to produce the write-up. We'll look at perform write-up later, so I'll mark it for later review. In this section, we get a review of the draft paper and save it. The draft paper is sent to this perform review procedure, which we'll look at later. Catch any errors that happen during the review. If improvement is requested by the initial call to this whole process, then improve on the draft by sending it to perform improvement. We'll take a look at that later. And the review, which is passed, includes the entire text of the research paper. So it passes the LLM the review and tells it to improve on it. Here, produce the improved write-up in PDF format. Perform another review on this new draft. Save that review. And finally, handle errors. Return success if it succeeded. More error handling, and handle the logs. Perform experiments. This procedure plans and executes the experiments required to test the current idea. Here it is setting up an iteration counter and a run counter to make sure that it runs the right number of experiments. And also setting up a prompt that describes the idea and instructions for experiments. Here it's repeatedly iterating and running the experiments. We'll take a closer look at run experiment later, which takes the run number and returns a prompt to update experiment.py to rerun. Finally, the rest of this generates plots and captions and runs the code generated in plot.py after the LLM runs these instructions right here, which, to summarize, just says to generate the best plots to show their results from experiments. Now here's the process to run each experiment. First section is to run the code generated in experiment.py and get the results. Here we set up the command, reading from experiment.py, generated earlier. Then try to run it as a sub-process. Here, handling any errors. And save the results. Here we build the next prompt and return it. And the next prompt essentially says to the LLM, either execute the next step in your experiment, or if there's a problem, then replan the experiment. More typically, it'll be just execute the next step. Here's some error handling, and that's how you run an experiment. Perform write-up. This procedure generates the scientific report to present the experimental results obtained with the code generated previously. Essentially, this part is generating LLM prompts for each section, each with writing tips. Notice that there are tips for each section, some generic tips just to say what each section is. So here we're prompting the LLM to generate an abstract. And then for each section, intro, background, and so forth, prompt it to fill in that section and send that prompt to the LLM. Here, prompt it to find the related work and write that section. Here, building a list of citations. And the prompt literally asks the LLM, identify where citations should be. So the LLM is doing all the work here. Next, prompts the LLM to review each section, make it concise, and check for errors, and just refine each section individually, one at a time. Finally, last step is to generate the final output. Perform review. This generates reviews of drafts of scientific papers to be used to generate improved versions. First, if requested, get human written responses to reviews to use as examples. If multiple reviews are requested, then here the LLM generates multiple reviews of the same paper. Attempt to get the text of each review. So there's some error handling in there. Here, attempt to get a meta review. Essentially puts all the reviews into a long string. Review 0 is this, review 1 is this, review 2 is this, and then prompts the LLM to combine and summarize them all. Now, as with anything, this may fail, and if it does, just take the first review and throw the others away. Next, for each scoring dimension, calculate the average, update the model's thought record, just saying, yes, I made a meta review that combines everything else. And here's the other case where only one review was required, and in that case, just get one review and use it. Here we prompt the LLM to think again. So it gets a reviewer reflection prompt that asks it about considering other important evaluation factors. It could start again if there are big problems, but for the most part, it's told not to deviate from the main idea. Now note that the initial meta review counts as the first reflection, and that's why it only loops up to num reflections -1. Here we handle boundary conditions. Finally, return the thought record if and only if asked by the caller, and otherwise just a review. This part makes use of the review. What it does is write text to introduce the review, which includes the current draft, to the LLM, and pass that text to the LLM to generate an improved draft. That's it. So, there you have it. A few well-written prompts to an LLM can result in an endless source of original scientific research. I'd like to say what Sakana AI plans for future work, but I did not find anything in English, and they could easily farm out future research to the AI scientist anyway. So, see you next time!